Good morning, everyone. Ooh, that's nice and loud. Welcome to the final Back to Class talk of the 2013 season, which is actually the 11th season that we've shared our outstanding faculty with you on our home football game weekends. So thank you very, very much this morning for joining us. Obviously, your being here is what makes it so special. My name's Martha Beatty, class of 1976. For those of you who I have not yet met, I'm the Vice President for Alumni Relations here at Dartmouth, and am very lucky to have such an incredible team in our continuing education and travel department. Through our Dartmouth for Life programming, we hope to add value to the lives of our alumni through all stages of our lives. Part of that is providing alumni with incredible learning opportunities of all kinds. Certainly this morning is an example of that. But we also have fabulous travel programs. Our Dartmouth on Location programs, I think, are quite extraordinary. And I'm just going to ask you this morning if you would, at some point, take the time to go to our alumni.dartmouth.edu and check out all the offerings that are available throughout the year, not just on home football game weekends in the fall. Personally, I'm always grateful for a gentle reminder to turn off my cell phone. So if you haven't yet done that, I think Professor Virginia would appreciate it very much, as would everyone sitting next to you. I also want to thank my Alumni Relations colleagues, Robin Albing, who is the new Director of Continuing Ed and Travel, and Danielle Sparks, who is our new Assistant Director, who has done all the work for this morning, and really they have just brought energy and creativity to our department, and they're standing in the back, and I just want to thank them very much for a great season. Thank you, guys. This morning, like those over the last 11 years, could not happen without the generosity of our remarkable faculty. So I want to thank Professor Ross Virginia right now for his time and for sharing his extraordinary work with us this morning. Ross, AKA coverman of the Dartmouth Alumni Magazine, is the Myers Professor of Environmental Science. He's an ecosystem ecologist interested in human influence on biogeochemical cycles in terrestrial systems, with an emphasis on understanding how climate change alters plant-soil interactions and the ecology, biodiversity, and functioning of soils. Ross is a principal investigator on the McMurdo Dry Valley Long-Term Ecological Research Program and serves as the director of the Institute of Arctic Studies within our Dickey Center for International Understanding. He also directs Dartmouth's graduate program in Polar Environmental Change, IGERT, funded by the National Science Foundation. There's a fabulous video on YouTube, if you haven't seen it yet, done by some of the women in his IGERT program that talks about sciences for women. And if you haven't seen it, you should go find it on YouTube. It's really extraordinary. He is the co-director of the University of the Arctic Institute for Applied Circumpolar Policy, which promotes discussion and analysis of critical issues facing the circumpolar north and its peoples as a result of climate change. He has a PhD in ecology from the University of California at Davis and joined the Dartmouth faculty in 1992. So please join me this morning in offering sincere thanks and a very warm welcome to Professor Virginia.
Well, good morning, everyone, and thank you for being here, and thank you, Martha, for that very nice introduction. And also to everyone who works with the alumni at the college for putting these events on, and for you for showing up and coming out and this football morning, and I hope we do well today. So I'm going to talk about what I do, and I'm going to use how I teach and materials that I use for my teaching to introduce you to some of the issues that affect both poles. I caught polar fever, as we call it in the business, a long time ago. And I'm now preparing for my 19th research trip to Antarctica, to the McMurdo Dry Valleys, a polar desert region. I'm currently working in Greenland. I've worked on the North Slope of Alaska. And so I'm going to share with you some of the science, some of the processes that are driving accelerated change in the polar regions. And then I want to talk about what are the impacts on people. The science is actually fairly straightforward once you kind of work through it. the messy part, the hard part's really the politics and the policy, because that's where people are. And that's probably where most of you have an interest. So I'm going to lay these things out, and then we'll get to the issues, and hopefully we can generate some pretty good discussion. Okay? This is a picture of me, and that it's hard to see there. That's a penguin. That's the only penguin photograph in this talk, all right? That's Cape Bird on Ross Island, one of the most amazing, remote, and beautiful places I've ever had the opportunity to be to. All right, well, it's pretty easy. If you pick up any major newspaper, there's something about the Arctic and the Antarctic almost every day. This is just in the last month, just some of the stories. A huge mega development project approved for Greenland, the largest economic activity in Greenland's history, financed by Canada, the United Kingdom, and China. Okay, moose die-off, that's actually affecting us. Climate change is affecting the health of many animals in northern systems. How many of you heard about the Arctic 40, the group that are now in detention in Russia for trying to occupy the oil derrick platform? That's a huge issue right now, and what's going to happen there. Antarctic marine systems and reserves and fisheries, global fisheries, huge issue everywhere, particularly in the Arctic, but also the Antarctic. And then there's a climate change prediction, scare, story, prognosis almost every day in the paper, that last one. So this is the backdrop, and this is how I try to engage students, is that when talking about the polar regions, it's really about now, and it's really about our connections to these regions. What happens in Hanover matters to the Arctic, matters to the Antarctic, and hopefully that comes out. There's been a huge focusing of interest on the Arctic and the geopolitics of the Arctic and the race for new resources. And this really started peaking, coming on the radar screen maybe about 5-6 years ago. And talks of the great game, the conflict between Russia and the US, the geopolitics, and being refocused on the Arctic as the new place of potential conflict in global politics. And here's a quote from Scott Borgerson, and I think in particular on the right side, talking about the many characters involved in this new potential great race, and which could lead in multiple directions. So what is the future of the polar regions? What are these multiple directions? And what are the options for achieving a more sustainable future for these amazing environments? I teach a course, it's called Environmental Issues of the Cold Regions, and the students call it Pole to Pole. And I teach it in the spring term. I usually get about 70, 75 students. They're from all kinds of different majors. And I think I try to pitch the class in a way that it's truly part of Dartmouth's liberal education tradition. So it's very multidisciplinary, interdisciplinary, and everyone is welcome. And so I bring them into this, and we first start as tourists. You know, why do people even go to the Arctic? And travel is really important. I urge all of you to get on one of the alumni trips, either to the Arctic or to the Antarctic, see these places. We learn about the geography. Then we learn about the role of the polar systems in Earth's climate system and the biogeochemistry of the Earth. History is central to all of this. You can't understand the Arctic without understanding the Cold War. That's the basis for everything that's happening there, is actually that legacy. And then it's about people. Who are the people there? The indigenous populations of these regions are central to understanding the future of that place. And we have an obligation to think about their livelihood, their lives, their culture in sustaining the Arctic into the future. And then the messy part is the politics, and we'll get to that in just a little bit. Why Arctic and why polar stuff at Dartmouth? Well, a lot of it just flashes back to this character, Villamar Steffensen. And is there anyone here that took a course or knew Steph when he was here at the college? Oh, that's wonderful. I always regret that that's something that I don't have the opportunity of. Steffensen was the last of the heroic age explorers in the Arctic. And he had 3 expeditions to the north, and he really reshaped the way in which exploration was done at that time. He used traditional methods. He learned the language. He used traditional clothing. He adopted Inuit diet. And when he came back from the Arctic, he went on the road and he promoted the Arctic as the friendly Arctic, which may or may not really be accurate. But he did introduce the American public and the American government to the Arctic as a place of importance well into the future, and that we better start learning more about the Arctic and paying more attention to it. And that's really his legacy. He joined the faculty, he developed the Northern Studies program, and he's had a permanent influence on many, many people at Dartmouth. The Institute of Arctic Studies, which I direct, is really a legacy of Steffensen. And our job is to promote everything Arctic, everything polar at Dartmouth, to help students get to these places, to help faculty develop research, to bring people in from the outside to engage with the community, and also to help Dartmouth be part of the high-level policy discussions that are so important. So this is a very multidimensional institute. It's part of the Dickey Center for International Understanding, because Arctic is definitely international, and we're quite proud of what we've been able to do there. Okay, so some quick background here. What fundamental information about, I'm going to talk about the Arctic and a little bit about the Antarctic. So the Arctic is to the north. That's the most important thing to remember. I've worked with 5 different Dartmouth presidents, and there's one in particular that never could sort that out. And so it's literally ocean surrounded by land. That's the important thing about the Arctic. And the whole world is interested in the Arctic now. The international interest in the Arctic is just tremendous. And there are 8 nation states that have a stake in the Arctic. And there's something called the Arctic Council, which helps them talk to one another, and I'll mention that. We'll talk about that in a little bit. The Antarctic, to the south, that was the tricky part for this president. And it's a continent, and it's surrounded by oceans. It's just the inverse of the Arctic. There are no people that live there. That changes everything as well. But there's a very long-developed international treaty which regulates the Antarctic, and that's a very different geopolitical situation. Okay. So let's start with the Arctic. I said history is important, and I also love maps. And I'm sorry this is a little hard to see, but this is a map. This is a map. This is the Arctic Ocean in the early 1600s. And starting in the 1500s, people realized that maybe if you could take a ship from Europe and you could go across the top of the world, you could get to Asia in a matter of a few months instead of a 2-year journey around the Horn or around the other way. So it would just, if you could find a way across the north and could control that route, you'd be the most powerful trading nation on Earth. So the Northwest, what we now call the Northwest Passage, but a route across the top, that was the prize. That was the geographic and economic prize of the era, and many, many people tried. But they didn't really know what was there. But they drew maps anyway. You know, so what? Let's make a map. So here's a map, and here's the Arctic Ocean. Here's Europe. And you see that they've got a bunch of land there, but there's actually open water all the way through here. They envision that somehow there's a way through. We just have to find it, and that's the vision. So many, many, many people tried. Probably the one many of you have heard about is John Franklin and his expedition. This was actually his 4th expedition. In 1845, he got 2 ships together that had recently returned from the Antarctic, the Erebus and the Terror. And he had already killed a number of people on his previous expeditions. And so why you would want to sign up on a ship called the Terror with John Franklin is maybe beyond me, but people stood in line to do this because this was the moonshot of the day. If you were on the ship that found the Northwest Passage, you would be famous. And this was a source of national pride. So he set off in 1845 in these 2 large British ships with the intent of bashing through the ice, essentially, to get across the top of the world. He left in 1845, and years went by, and no one heard anything from John Franklin. But at home, everyone had this vision of, that he was going to be successful. This was the best of the British Navy. And so here's a newspaper in 1849, right? I mean, remember, there's no cell phone, there's no sat phones. But people were so engaged in these expeditions that they made up stories about what it must be like for them. So here they are, it's hard to see, here's the ship, and they're building like a little English cottage out of ice. I mean, this is what they imagined was going on. Actually, by this time, they were starving to death. The ship's been crushed. They were walking across northern Canada and dying during this time. But this is the fanciful image of the north, this romantic place. So after John Franklin, many people went up looking for him. And over the next 20 years, many expeditions went up there. And in fact, what happened is they sort of filled in the map, right? And we knew more and more about the Arctic from John Franklin's failure. That's the legacy, actually, of his thing. So after that, a long period of time went by. Nothing happened around Northwest Passage. And then this character, Amundsen, in 1905, took a much smaller ship, shallow draft, stayed close to the shore, and he achieved the Northwest Passage. It was a 3-year expedition, but eventually the Northwest Passage was done. He took the sort of same approach. This is the same guy that 6 years later got to the South Pole, right? By moving fast, being lean, being smart. And so Amundsen achieved in 1905. We knew that there was a Northwest Passage. And then we promptly forgot about it. World War I came. Yeah, it was there, but so what? And then the game changed. 1969, oil's discovered at Prudhoe Bay. All right. So huge resource there, but how are you going to get the oil to market? So the environmental impact statements had 2 options. One was to ship the oil across and use the Northwest Passage with icebreakers at that time. Or number 2 was the pipeline. So in 1969, they retrofitted the Manhattan tanker. They put 1 barrel of oil on it, and they sailed from east to west across the Canadian Arctic to try to get to Prudhoe, Alaska. And they did it. But it was also a disaster. It was very difficult. The ship kept breaking down. And they also forgot to ask Canada's permission to sail across what Canada claims as Canadian waters, setting up the first of the geopolitical debates about the Northwest Passage, the ones that continue today. So it was feasible but not practical, so we now have the Alaska Pipeline. Fast forward, 2007. This is a satellite image. This bright thing here, this very reflective space, this is Greenland. And this line here shows the Northwest Passage across northern Canada up into Alaska. And for the first time, using satellite imagery, we could see that the Northwest Passage had melted open, and that it was achievable. The other passage that is already actually being used even more is the Northeast Passage, or the Northern Passage, Northern Sea Route, which goes across northern Russia. Okay, so the Northwest Passage has now been achieved, but it's been achieved because the ice is melting. This is not anything that Amundsen would have ever imagined, certainly not Franklin. Okay, so why is that? What happened? Why in 2007 is the ice finally going away, and what's driving that? So what I want to talk about now is some of the science behind the rapid changes in ice, in the cryosphere as we call it, in both the Arctic and the Antarctic. What's the science that's accelerating change in these regions? Well, one of the things we know from just measuring temperature is that the Arctic is warming faster than any other region on the Earth, okay? And this is a global map. Again, it's difficult to see, but anything that's sort of this darker color here is warming 1 to 2 degrees centigrade during the period 2000 to 2009 relative to this long line average, okay? So you can see that the north is warming faster. Why is that? And what are the consequences for that? So we know that the north is responding, but it's also amplifying the signal that we see as the whole planet begins to warm. And this is where science is really important. This is the exciting part of science, but this is also the disturbing part of the puzzle. And we've come to learn that this is a mechanism that's accelerating the loss of ice in the Arctic. We call it the ice albedo feedback. And we're all experts in albedo. You know that a bright white sheet of paper reflects most of the sunlight that hits it. About 90% of the incident energy that hits bright white clean snow is reflected back to space. If you take that snow, melt it away, and replace it with deep blue ocean water, it absorbs about 90% of the incoming energy, so it heats up, okay? So here's early spring in the Arctic. It's bright white. new snow on ice, okay? And with greenhouse gases in the atmosphere, what's happening is that the temperatures are warming and the melt in the Arctic is starting earlier and earlier each year and ending later. So we have more time for melt to happen. So we have this bright white area that's reflective, but eventually it warms up and we begin to get melt pools on the ice. And you see what's the color of the melting, these melt pools. They're very dark in color. So they begin to absorb energy, sunlight energy. They begin to melt, which makes them larger. They absorb more energy and they melt more. So this is what we call a positive feedback mechanism, or the ice albedo feedback. And so what's happening now is this cycle is starting earlier each year and is accelerating. And so the result of that is this. This is a graph showing the extent of Arctic sea ice starting in 1978, the first year we had a satellite that could look at the Arctic Ocean, on up to 2013. And you can see it's up and down. And this is the first year that the Northwest Passage opened, okay? But it's pretty clear that trend is strong, is moving in a direction that's pretty worrisome for the future of sea ice, summer sea ice in the Arctic Ocean. The rate of decline is 24,500 square miles per year, and that's larger than the combined area of Vermont and New Hampshire, if you want to scale that. So this is a big thing and a big issue. The sea ice is going away. All right, well, what are the implications of that? Lots, many different things. More shipping is possible. Oil and gas exploration of the continental shelves just off the nations in the Arctic Ocean will be easier. With more commerce comes more potential for pollution, more health impacts on small communities along the Arctic Ocean. And it also changes the food web and the ecosystems and the animals that require ice to be alive. And of course, the most prominent one, and one you read about the most, is the polar bear. The polar bear is completely ice dependent. It's a marine animal, it swims, but it needs to hunt from ice. And without sea ice, the polar bear is eventually is doomed. So, and you also notice that the polar bear sits on the top of this entire food web. So anything that happens up here has ramifications all the way down to there. So everything is connected. And these rapid changes are really worrisome to understanding how the ecosystem will function into the future. Okay, so we have one feedback that's driving the loss of ice in the Arctic Ocean. There's another feedback that's probably less well known. It's happening more slowly, but perhaps its importance to the entire planet is even more significant. And this is the fact that as the Arctic warms, the permafrost, the frozen soils, are beginning to thaw deeper and deeper each year. And this creates another one of these feedback cycles. So scientists, the part of the Arctic soil that thaws each year, that allows activity for plant roots and life, all the animals that live in soils, the microbes, the fungi, the little critters that crawl around and make the world work, we call that the active layer. That's where the biology is. And in the process of biology, right, just like we're sitting in this room and respiring, CO2 is evolved. All life respires. So you have an active layer of a certain depth, and it's emitting a certain amount of carbon dioxide. But as we begin to warm the Arctic, each year, that active layer gets deeper because the soils thaw more each season. Previously, this part of frozen soil, which has lots of goodies in it, has lots of organic matter, carbon, things that life could use, but it's frozen, so it's not available. But as we thaw these soils, we unlock this new resource for life, this new organic matter, which is now can be decomposed, just like in your garden. This stuff can be decomposed by that life and then returned to the atmosphere as carbon dioxide or methane. These are potent greenhouse gases, which then feed back to increase temperature even more. All right? So you can see how this process, again, is circular and self-reinforcing. All right? So the two big, the science take-home message here are that there are two things changing and accelerating the rate of change in the Arctic. One is this ice albedo feedback, which is driving ice down in the Arctic Ocean, but it's also melting the ice sheets more quickly. And glaciers, it's all the ice is subject to this loss because of albedo. The other is changes in soils and increasing CO2 to the atmosphere. okay? So I want to talk a little bit about the soil thing because you heard from the introduction, I do some of this work myself, and it's also an opportunity to highlight a Dartmouth graduate student, PhD student, Julia Bradley Cook, who works with me in Greenland. And we're looking at this polar amplification process where small changes are amplified to larger changes. That's what polar amplification is about. So it's a little hard to see here, but this is Greenland. This is near Kangerlussuaq, Greenland. This is the Greenland ice sheet in the background, lakes, tundra system, just one of the most beautiful landscapes in the world. It's just amazing to get there. That I have the best job in the world and I get to go to these places. And I get to do it with students, which makes it all the better. So Julia is part of this program that was mentioned in the introduction, IGERT, Polar Environmental Change. And this is a graduate program that's funded by the National Science Foundation to start with NSF funding and be continued with Dartmouth resources. And it's really an innovation. We're taking students from different disciplines, engineering, ecology, and earth sciences. And we're putting them together now. Instead of sitting in their home departments, they take courses together, they learn together. And then we take them to the field together. We do an intensive 6-week field seminar in Greenland. And we spend part of the time in the tundra learning about plant soils, water systems, insects, the animals, the muskox, the caribou. How does that whole system come together and work? And how does climate change influence that? We go to Summit, Greenland, the center of the Greenland ice sheet, 2 miles of ice beneath our feet. This is where all the climate records are coming from the deep cores that are collected there. And Summit Station and all that research there really springs from CREL, our neighbors up the road, the Cold Regions Research and Engineering Lab, which is also a partner of Dartmouth. Students get to go there. We get to go to the fjords and the marine ecosystems. And we learn about the science behind change, but most importantly, the students learn how to improve their science through collaborating and learning from different disciplines. And I can lecture too, as I'm doing now, till the cows come home. But when you put students together in these places and you kind of get out of the way a little bit, that's when the magic starts. And that's what they carry back. So once they have that science background, then what's really important is, why does that science matter and who does it matter to? Most scientists go do their work in Greenland and then come home. The next step is we take them to Nuuk, the capital of Greenland, to actually meet people who live in Greenland, who care about Greenland. What science does Greenland want from Western scientists coming in? How are they going to use that science? How do they form relationships with people in Greenland so they can work with people in Greenland? And what are the policy issues that are really central to the future of Greenland? So that's the piece that really makes this program very special. And so we're training a whole new type of graduate student, and I think it's it's what Dartmouth does. It's interdisciplinary, it's cutting edge, and we care about people as part of our science. Okay, commercial's over. So soil carbon, why do you care about soil carbon? There's more carbon locked up in Arctic soils. There's twice as much in those soils as there is in the Earth's atmosphere. All right, we're all worried about how much CO2 we're emitting from our industry, but there's a heck of a lot more carbon stored in soils than we're sending up in fossil fuel combustion. So small changes in that active layer through time, releasing more carbon to the atmosphere, can erase a lot of the good work that we're trying to do in cutting CO2 emissions from our fossil fuel emissions on the planet. So we need to understand what that biological input's going to be and how sensitive it is to future climate change. That's the key. It's really important. It's important to policymakers. Soils matter. So Julia's up there. She's measuring the change in the thaw layer in various vegetation types. How is that changing? She's measuring the temperature regimes in the soils. She's looking at the soils themselves under different vegetation types and analyzing how much carbon is there and where is it. And this is a lot of work and really intensive work, and she's done an excellent job with this. And then what we also want to know then is how much carbon is being released from these soils. So this is Julia in the field, and she's got a bug net on. Mosquitoes are the bane of any researcher in the far north. And she has an instrument here. She's actually measuring the amount of carbon dioxide being released from these soils. And she's doing that in all these different vegetation types. Okay, so temperature, the amount of carbon in the soil, the amount of carbon being released from the soil. And then to put this all together, she's using satellite remote sensing. This is a satellite image of this area of Greenland. Here's the ice sheet. And all these colors represent different vegetation types. So she's mapping the vegetation and categorizing it. So now she's got vegetation, she's got soil, CO2 flux by vegetation. She can begin to model these relationships. And she can take satellite images from other areas now and predict how much CO2 might be released from those landscapes based on this work and the model that she's building. So this is really important work, and this is how the scientists are contributing to understanding the atmospheric CO2 issues. Okay, so we've talked a little bit about why the Arctic is changing fast, these two feedback mechanisms. How is that playing out? You know, what does that matter to people, and what are the geopolitics of this? This is one of my favorite maps of the Arctic. Basically, this is the Arctic Ocean, and the water's been drained, and you're actually looking at the ocean floor here. Here's Greenland. And I think what you can see here is these areas here, these are the continental shelves. And this is Russia here. But you can see, and then this area in the middle here, this is the deeper part of the Arctic Ocean. Okay? But you can see there are vast areas of relatively shallow waters in the Arctic Ocean. It's the shallowest of the Earth's oceans. And as the ice goes away, this is becoming more and more accessible for oil and gas and mineral exploration. All right, so who gets to go there? How do we decide who gets to develop these resources as the ice goes away? Well, we have an international treaty called the Law of the Sea, and nations can make claims on the ocean bottom floor. And this mosaic, I call it a mess. Here's the ocean. All these different colors, and this key here, these are all different international claims to the Arctic Ocean seabed based on proximity to a nation, based on mapping of the ocean floor, based on projections of your national boundary. There's all these different rules. And there are significant areas where national claims actually overlap, where the US and Canada claim the same area, where Russia and Norway have overlapping claims to the ocean sea bottom. And in the past, that wasn't so important because no one could get to these resources. They were covered by ice, but the ice is going to be gone. When I first started teaching my pole-to-pole course about 8 or 9 years ago, the projection said that the sea ice would be essentially reduced or gone enough so you could have shipping across the Arctic Ocean around 2060, 2070. Current estimates are 2017, and I think the smart money is around about 2030. That's how much it's changed. That's this accelerated change that I was talking about. So we've got a mess up there. Fortunately, most of it's fairly straightforward, but there are plenty of areas where there's contested resource access internationally. In addition, nations can kind of claim the ocean bottom out to about 200 kilometers or 200 nautical miles, but that leaves this big area here outside all of those boundaries. It's often called the donut hole. And this is truly international territory, international waters. And this is part of the race for resources. This is why Korea, China are building icebreakers. This is why Singapore is now a participating member in the Arctic Council. The rest of the world sees the Arctic and the Arctic Ocean as the new frontier for resource, particularly around energy. And this is a challenge. This is particularly a challenge for the people in the Arctic and the Arctic nations. So how does this play out, and who are the people that are affected? There are about 160,000 indigenous peoples in the high Arctic, the Inuit. They live in Alaska, Canada, Greenland, and Chukotka in Russia. There are about 4.5 million people that are not indigenous that live in the rest of the Arctic. It's not a lot of people in terms of the global population, but that's their homeland. That's where they live. And they live in a cold place, in a cold climate, and their heritage is tied to the cold. So the changes that they're seeing now are unprecedented. They're not driven by their carbon emissions, but they are receiving these changes. And I think it's a very important thing to remember as we think about these vast lands, the people and the societies there are deeply embedded in this change. Here's also the flag of the island nation of Tuvalu. The small Pacific islands are also very connected to all of this because they're going to see sea level rise and are seeing sea level rise. Projections now from this ice albedo feedback, melting of the Greenland ice sheet and mountain glaciers, and contributions from Antarctica, that by the end of this century, about approximately 1 meter of sea level rise. It doesn't sound like a lot, but think of Superstorm Sandy in New York and add another meter of sea level on top of that. Think about Boston and how much Boston would be affected by an additional meter of sea level rise. And the small island nations, some of them are essentially disappearing. Certainly their ability to sustain their coastal communities is directly influenced. So these changes are global. They're transmitted through the oceans and through the atmosphere to all people, even though they might look like Arctic problems specifically. So our perception of this has changed dramatically too. Here's 2006 cover of Time magazine, and the polar bear now has become the iconic symbol of climate change for the whole planet, right? Before that, it was something else. We were all worried about rainforests, remember that? We used to talk about biodiversity, and now everything about it's about this image of the polar bear on the little disappearing ice. Be worried, be very worried, it says. And it talks about the Earth at a tipping point. That's 2006. Here we are, 2012. The Economist cares about the Arctic. And the vanishing north. But what's the take here? What the melting in the Arctic means for trade, energy, and the environment. It's a very different perspective on the Arctic. As, you know, one is a natural ecosystem, the other is about an indigenous homeland. Now we're talking about energy, environment, trade, development. And these are the two lenses around which the issue and the great debate over the Arctic is playing out. So let's shift now a little bit into the issues. I'll try to get through this quickly so we can have some questions. What are the things that are worrisome, that are tricky, that are hard? I've already mentioned the overlapping claims to the ocean floor for oil and gas. Canada, the Northwest Passage. Canada claims the Northwest Passage as an internal strait. It's actually going through many different islands and areas. And so Canada, that's Canada. Northwest Passage is Canada. The United States disagrees. That's why we sailed to Manhattan into there. We recognize the Northwest Passage as an international strait connecting two oceans. That means that Canada can't control that passage. We disagree. We haven't resolved that, but that is a major geopolitical issue. Militarization of the Arctic Ocean. As the ice goes away, there are more opportunities for militaries to exert influence and control in the Arctic. It used to be all underneath the ice. During the Cold War, it was all submarines. Now, Russia no longer has a submarine fleet, but they have many ships, and they see the Arctic as their frontier. Russia, when the Soviet Union broke up, they lost all their lands and influence to the south. So what do they have for the future of Russia? It's to the north. It's to the Arctic Ocean. That's their long boundary that they control. So Russia is very, very deeply engaged in planning their strategies for the Arctic, and they sometimes flex their muscles about the military implications of that. I've mentioned the indigenous peoples. The Inuit who live across the circumpolar north were there long before international boundaries and borders, long before they were Canadian Inuit or Greenlanders. They were Inuit. And they have a perspective about the future of the Arctic that is different than a nation-state perspective about the future of the Arctic. And how do we account for that? How do we engage them in that? And then finally, all of the rules around what happens in the Arctic Ocean. The international community has signed on to something called the United Nations Law of the Sea. There's only one great power in the Arctic that has not ratified that treaty, and that's the United States. That's a major international policy problem for the Arctic into the future. We adhere to the tenets of the treaty, but we've not ratified it. Every president since Reagan has endorsed the ratification, and it's stalled permanently in the Senate by a relatively small number of people, but that's where it is. It's still stalled. So these are the policy issues and problems. They're popping up more and more frequently, just like these positive feedbacks are changing ice and soils. The rate of interest in development in the Arctic is accelerating too. All of this in the last week around Greenland, a place very special and important to me. I have many good friends there. This Ishua iron mine, this mega project was approved in Greenland. It's the first plans for Ishua mine were in 1970s. And actually people at Krell were involved in some of the initial geologic exploration for that. Huge implications for the future of Greenland. They're going to need 2,000 to 3,000 workers to come in to begin to develop the mine. They have 57,000 people in all of Greenland. And they're going to bring 2,000 to 3,000 international mine workers, most of them from Asia, into Greenland to develop this project. The iron ore is going to China. The investment money is from the United Kingdom and Canada. At the same time, in the same week, Greenland approved the mining of uranium in South Greenland. This is a huge issue for Greenland. Greenland has been part of, it still has a relationship with Denmark. Greenland has self-government now, but it's part of the Kingdom of Denmark as well in that same way. In the 1960s, a B-52 bomber crashed near Thule Air Force Base in northern Greenland. We still have Thule Air Force Base there. And 4 hydrogen bombs were dumped on the ice and recovered, but a number of people, Greenlanders, were exposed to radiation in that process. So Greenland's had a long history of being very sensitive to issues around radiation, around military presence. And so the Greenland government approval of uranium mining is a hugely contentious issue and represents the schism in Greenland now over development versus environmental protection and protection for traditional ways of life, particularly for the small coastal communities. And then finally, the same week, the Greenland government is discussing reducing or eliminating funding to something called the Inuit Circumpolar Council, the ICC. The ICC is the group that represents the Circumpolar Inuit. It's an indigenous peoples organization, very powerful one. It's part of the UN Permanent Forum on Indigenous Rights. They're a permanent participant in the Arctic Council, which I'll describe in a minute. So they're a very powerful organization internationally, and they potentially are losing the support of the Greenland government. This is OClock Linga. He's president or chair of the Inuit Circumpolar Council. We've worked with him. He has a very close relationship with Dartmouth, and I'm very proud that he was awarded an honorary degree by Dartmouth in 2012. He's struggling with all of this that's happening in Greenland right now. Okay, so let me finish the next couple minutes here, and then I'll have some discussion, hopefully. So how do we make sense of all this? What are the rules that help us find our way through these political issues and help protect the future of these systems? The Arctic, we have something called the Arctic Council. So there are the 8 nations Arctic nations, US is one of them, obviously, sit on the Arctic Council. It's an intergovernmental forum, okay? It's a high-level forum. Every nation has an ambassador representing their interests on the Arctic Council, except the United States. We have a senior official. We've not upped our participation to the level of an ambassador. And we can maybe talk about that, but the US has a very complicated history of relationships around entering into groups like this, where we feel we're ceding too much power to others. So, but that relationship's changing, but there's no binding authority for the Arctic Council. They meet, they have participation by indigenous organizations, and they operate by consensus. But it is the place where these issues can be talked out, and it's very important to the future of the Arctic. The Antarctic, I've talked very little about it, but the same changes we see in the Arctic are happening there, but more slowly, because the Antarctic is much colder. It's responding more slowly. But the trends are the same. Temperature change, ice mass loss, changes in the oceans, changes in animals. The other main difference is we don't have people living there other than scientists coming in and out. But the Antarctic is also part of this. But the Antarctic is in better shape. There's an internationally binding treaty, the Antarctic Treaty, formed in 1959. So the international community has set Antarctica aside for peaceful uses. There's no economic development going on in Antarctica, and the treaty has the binding power of international law. So Antarctica is in pretty good shape. There are issues and come and go. I showed you that headline around fisheries. Most of the problems relate to the marine environment near Antarctica. But that will creep closer and closer to Antarctica as the environment changes. So we're not home free, but we have a treaty. One of the big issues right now, at least among some political scientists, is do we need a treaty for the Arctic? Do we need something with teeth? Do we need the international community to come together and set up some more firm rules before this thing runs away, before the race for resources destroys the Arctic environment? So we have the Arctic Council. This is a place where people come together. And in addition to the Arctic Council members, the 8 nations, there's a category for observers. And up to fairly recently, there were not that many observers, not that many people cared to observe what the Arctic Council did. It was kind of a backwater, right? That's all changed. There's a race to get into the Arctic Council and be an observer, to have a voice, to exert influence. And there's a complicated process to get into the Arctic Council, and there's a long list of people trying to get in. And at the last meeting, just recently in 2013, China, India, Italy, Japan, Singapore, and South Korea are now observers on the Arctic Council. There was one important application that was turned down, and that's the European Union. EU is not sitting on the Arctic Council, and they're not there because they're blocked. The EU is blocked because of their position on the ban of trade of seal products in the European community. That's a very important issue for the indigenous peoples of the Arctic and the North, their rights to harvest seals and trade seal products. And so the EU is actually blocked by the very complicated politics and identities of the parties on the Arctic Council. But this is the place where the future of the Arctic is going to be talked about and probably determined. And I think for the near term, it's going to be this sort of soft policy forum where people come together, share issues, decisions are made by consensus, but there's no enforcement in most of the decisions that are being made. So what's the future? Is it going to be the great game of international conflict? Well, Russia's behaving badly right now in many ways. But around the Arctic, they have such strong interests in the Arctic, and they need technology and they need help, that they probably are going to be good players. So I'm fairly optimistic about international cooperation about the Arctic. And this is an op-ed that I co-authored with Jim Collins, former ambassador to Russia, and Kenneth Yalowitz, the past director of the Dickey Center. And our take is that actually the Arctic is one of the few places left where we have an opportunity for international cooperation. We've had a history of that. In some ways, maybe the stakes are low enough that we can come together to talk about what's happening there. And the rate of change is so fast that I think there's a sense of urgency that's not felt in many other places. So I think the Arctic is an opportunity. It's actually an opportunity to develop better international relationships between Russia, the US, and then drawing in Canada and the other members of the Arctic Council. So I'm going to end with this. This is a photograph that my graduate student took up at near Kangalusuk, Greenland last summer. A little hard to see, but there's a lake here. There's a lake here, and the Inuit hunters, caribou hunters come up here and right before opening day, and they all sit at the edge of the lake here, and they wait for boats to take them to the other end of the lake, because that's better access to the caribou hunting grounds. And so this hunter gathers a lot of junk that just accumulates there through time. And so he found this chair, he set it up, and there's this piece of wood here he set up, and he drew on it. And what you can't see here is this is like a picture window of a house. And there's a table here, and there's a couple of people sitting here. So he's like sitting there looking into his home. But then on the side here, it's a palm tree. And I don't, it's a very confusing picture to me. I don't know if it's just sort of a he had some time on his hands and it's kind of a whimsical thing to do, or whether that's a vision of change, and this person is contemplating perhaps a different Arctic. So it can go multiple ways, and I think it's what we do and what we expect from the U.S. in terms of Arctic policy is a big part of how this is all going to play out. So let me stop there, and I hope I've left a little bit of time for questions or comments and additions, and thank you so much for being very patient with me today. Question, comment? Yes.
Assuming there is a treaty, what should it say about drilling?
Wow, that's the big question. What should a treaty say about drilling? To me, the frustrating part is just because it's there doesn't mean we need to use it. And the environmental risks and the costs of exploiting Arctic coastal and oil is high. And the argument is that, well, we're doing it, Norway's been very successful in the North Sea, but it scares me, actually. And you look at, we have very limited response and cleanup capacity in the Arctic. There are no deep water ports across all of Canada and northern Alaska. We don't have the resources to deal with the accidents. And actually, the Arctic Council, one of their big issues right now is oil spill preparedness and prevention. So people are acting as if it's going to happen. If we had a treaty, I would prefer that there be a moratorium, at least a moratorium on oil drilling until we had a better handle on technology prevention, that we staged these cleanup facilities, and we had more time for debate. I don't think we're adequately giving, particularly indigenous peoples, time to think about what they truly want. And those communities are divided as well. There's no one voice on these issues. But personally, I think we need to slow down. We need to do better in conserving what we have and bump up alternative energy and see where we get, but not rush up there. That's my opinion on that. Yes?
So right now, is it up to the individual countries whether... So right now, is it up to the individual countries whether they decide to drill in their claims in the Arctic?
Yes, if they're within their territorial claims, essentially they have the access and the right to do that. What's limiting right now is although the oil is there and they have the reserves there, it's still a dangerous place. There's still a lot of ice, right? And even though that ice is diminishing, it's still there. Stormy waters, it's very expensive to get materials into the Arctic. So the economics of that are not as favorable as other areas. So the press will still be to extract natural gas and oil from easier places. But it's, the planning window for oil drilling and extraction is 10 to 20 years. That's how long it takes to develop the resource. So the plans are there now, the exploration is being done, and unless there's something happens quickly, like a treaty, we're locked in step that this is going to happen. Well, how about here on this side now?
I just came back from Iceland where it was very clear it was much warmer than today, several hundred years ago. And some people say that's due to solar reactivity, and the more recent data suggests the sun's becoming quite quiet. And, are we going to return to the same warm conditions of several hundred years ago?
Well, in terms of trying to predict future climate or deconstruct kind of what's contributing to the current warming trends, there are a lot of things going on. The solar activity is a piece of that, but the main driver is clearly the greenhouse gas emissions and interactions in the atmosphere, and then these feedback effects, which are now amplifying the temperature response. Iceland is changing quickly too. That we just had a group from Iceland here, and one of their big changes now is that they're getting these late seasons, they're getting storms earlier, or they're getting ice at elevations and freezing rains that they didn't used to get, and they're having die-offs of the sheep at the end of the summer pasture season. They lost like 30,000 sheep this past season. And so as it's getting warmer, they don't understand how to manage their natural resources as well. The quality of pastures are changing. The weather cycles are changing. So it's not all about temperature as well, as we all know. It's also about the extremes and the timing of events that are shifting. And that's one of the harder parts. How do we plan for a different seasonal world in these places? Yeah. John? Here's our mic coming.
Thank you very much. You pointed out the rather alarming trend, at least alarming from the standpoint of most of us, of the mining opening up in Greenland. As I understand it right now, to date, most of the black carbon in Greenland has actually come from U.S. and Canada or elsewhere. But is there a way in the mining projects that are presumably going to go ahead of ensuring that there's absolutely minimal soot or black carbon emissions generated locally, because that could dramatically compound the situation?
The question is by John Topping, who's the president of the Climate Institute, which has done an amazing amount of good work on climate change issues and policy. And he's talking about black carbon, which is the soot, the very small particles that come from combustion that land on the ice. And this is part of the albedo feedback that I didn't mention, is that these little black particles then absorb more energy and speed up the ice. So soot from combustion, from forest fires, all of that adds to the melting. So these development projects that are going on, like the ones in Greenland, they're right at the edge of the Greenland ice sheet. And so the emissions that they spew will end up on the ice sheet, and which will feed back to accelerate melting of the Greenland ice sheet at some level. Right now, no, they're relying on diesel and fossil fuels because the cost for alternative energies to run the mines and deal with the extraction are just not economically feasible. So that's the other unfortunate feedback, is industrialization also accelerates change in ice and melting of the ice sheets. So that's where we are. All the plans that involved alternative energy that were costed out were rejected in the environmental impact statement assessment for the mine. Right, front row maybe? Here's a mic coming.
Seem to be stressing the methane release from the permafrost freezing very much. I've always heard that was a kind of an unknown. Is that being forecasted reasonably well in the temperature forecast?
Yeah, okay, the question is, I mainly talked about CO2, carbon dioxide, in the soil feedback, but also occurring with that is methane, CH4. And methane is about 20 to 30 times more potent as a greenhouse gas than CO2. It's released in smaller amounts, but it's a bigger forcer of change. So methane is the other big mystery. And where people are concerned about methane is actually coming out of ponds and lakes. There's a lot of methane is released when you have lots of water and no oxygen. So it's in saturated sediments and ponds and these lakes. And as the permafrost thaws, there are more wetlands occurring. There's more saturated soil because there's a lot of water and it's still no place for it to drain in these very flat, environments. So methane emissions are going up as well, and a lot of people are studying that. And that's part of the feedback, that's part of the surprise. And all the estimated emission rates for methane, they keep being revised up, certainly not down. Not good news. Yeah, Martha.
Given your comments about the ice albedo factor and also the release of
Here's a mic coming for you, I think.
Given your comments about the ice albedo factor as well as the release of CO2 from the soil, both being reinforcing circles, are they stoppable? And if so, how?
Are these stoppable? We can certainly slow them. There's a legacy. The signal that's in the atmosphere now is there. The CO2. Everyone's trying to stabilize the atmosphere, right? And there'll be some new equilibrium, we hope, if we can do that. There'll be less ice in the Arctic. There'll be more permafrost thaw. The active layer will equilibrate at a new depth. The issue is, small changes now can have big payoffs into the future because this is a reinforcing cycle. And I think so that's the urgency coming from the science, and that's the hard part of dealing with the policy community, is getting that sense of urgency now that actually we need to act now to prevent even larger changes into the future. And that's a tough sell in terms of politics and with all the multiple needs that society has. Where are you going to invest your money? But That's the problem. We have 200, 300, 400 years of pent-up issues and problems in climate that are already in the pipeline now. Wish I could be more encouraging, but that's where we are. Nancy? The polar bears doomed? The question is, are the polar bears doomed? There's a map, I took it out, I now wish I'd left it in. Polar bears are divided into like 16, 18 different populations all the way across the circumpolar north. And of those, only one is actually increasing in numbers. And that's in northern Canada. A good number of populations are fairly stable, but most are declining. And then there's a whole, basically we don't even know anything about what's going on in Siberia and Russia. Part of the problem is we don't have good information coming out of Russia on resources, population, and change. We have very little data, yet they have the majority of the Arctic Ocean coastline. So a big push now internationally is to draw Russia into more research, more collaboration, and more data sharing, because we're working with just knowing about much of the Arctic, but we really need to know about all of it. So the future of the polar bear is tough. There's going to be sea ice for a very, very long time in some areas of the Arctic. This isn't going away in 20, 30, 40 years. There will be the last ice, is what some people call it, will be jammed up in the north western side of Greenland, up in there. And so polar bears may be able to survive in these areas or these refugia for a very long period of time. But there's going to be a lot of habitat where eventually they will go extinct. Yeah. Maybe way in the back, or either way.
Referring back to the previous question where you'd mentioned the question whether it's possible to arrest the cycle of climate change, and if so, how do we do that? And you'd mentioned that small changes can produce large benefits going forward. Has the science been able to identify at this stage which of those small changes are the most important, where we get the biggest bang for our buck if we're advocating from a policy standpoint for particular changes?
Yeah, so I mean, I think the main issues are still now the greenhouse gases in the atmosphere, which are the forces or drivers of change. And then black carbon is another component of that, because that's also an accelerator. There's sort of anything we can do to reduce carbon emissions, obviously. So it still gets back to fossil fuels and using them more efficiently. One of the things that's changed dramatically in the equation is fracking and the tremendous surplus of or at least increased access to natural gas. And that's changing the whole global energy mix. It's actually slowing down interest in gas exploration in the Arctic right now because it isn't worth finding it. So that's a new piece of the equation, and natural gas is cleaner than coal, so that's sort of good news. But if you just say, oh, we have more, so let's just use it, that's not the best approach either. A lot of people are focusing on methane because methane is a more potent greenhouse gas, and so anything we can do to focus on methane, you get a bigger bang for your buck. And there are significant methane emissions from agriculture, from flooded rice, other areas outside the Arctic where maybe we can begin to make improvements there, where we have more direct control and more access. So better management of agriculture is one of the key issues. And creating sinks for carbon, right? Making the world grow more plant biomass and storing carbon there. So the carbon sequestration is another way we can do this. It'll help anyway.
Maybe we could take one more question.
There was one in the back, maybe.
You showed a graph where you're talking about the change of Arctic ice depth, and I guess has this ever happened before in the history of the world? I mean, can you get a sense that in the last thousands of years or millions of years that Arctic ice or the climate change has happened like this before, and the Earth has kind of rebounded from it? Right.
So we've gone through multiple glacial cycles where I mean, Hanover used to be under ice, right? I mean, this is the glacial landscape here. So there have been periods where there's been less ice in the Arctic, and periods where there's been ice as far south as Connecticut. I think the issue now is that the Arctic is warmer now than it has been in the past 4,000 years for sure. and it's projected to get warmer and warmer. During warm periods, when the ice pulls back, that was the period when the rapid expansion of Inuit across northern Alaska into Canada into Greenland. That's when whaling developed. Ice has been both a barrier and also a resource, and I think it's the rate of change which is the issue now. Not that we haven't seen changes in ice, but nothing on this scale in this time frame. Okay, well, thank you again. Enjoy the game.
Hello, my name is Danielle Sparks, and I'm with the Alumni Relations Office at Dartmouth College. I just wanted to thank Professor Virginia for such an insightful and informative talk today. We really appreciate it. We hope you all enjoyed it. And I'd also like to thank you all for coming to our last Back to Class lecture. And if you missed any of our series, we had 5 altogether. They've all been recorded, and they're on our Alumni Relations website. So just check it out, and they're all there for you. And now, I'm going to do the raffle for you all for the Dartmouth camera case. And the winner is Ross McIntyre. So raise your hand, I'll give you the, great. Thank you very much for coming. And there's coffee in the back, so thank you.